Hi guys, this is Mrs. Vaughn. This video is for my Math 7 class. We are going to begin section 3.5, least common multiple. I'm going to start with the worksheet so we can do our lesson opener. And I'll cover a couple of definitions and then we'll move into the PowerPoint. So first, this is the worksheet that you should have gotten in your email. What we're wanting to do is find the next three numbers in each sequence. So the first one, they give us 2, 4, 6, and you need to tell me the next three. So hopefully you can see that between the three numbers given, you have a difference of 2. So 2, 4, 6, you should have 8, 10, and 12. For the second one, we have 4, 8, 12. So you can see that the difference between each of those is 4. So 12 plus 4 is 16. 16 plus 4 is 20. And 20 plus 4 is 24. So these are also multiples of 4. And then our last sequence here is 6, 12, 18. So that's 6 times 1, 6 times 2, 6 times 3. 6 times 4 is 24. 6 times 5 is 30. And 6 times 6 is 36. So those are the last three in our sequence. All right, so let me go ahead and switch over. Okay. We're going to get over into our PowerPoint here in just a second, but I do want to talk about a couple of terms. Remember that common multiple means any number that two factors divide evenly into. So for example, for the number 8, 2 or 8 is a multiple of 2, 8 is a multiple of 4, and then 8 is a multiple of 8. Now, least common multiple, as you will go into in a second, is found when two or more numbers are compared. The least common multiple is the smallest positive common multiple of those two given numbers. So for example, if you have 2 and 4, the least common multiple is 4 because 2 divides into 4 and 4 divides into 4. Next, real quick review of the previous section. We talked about greatest common factor. So any number that divides evenly into another is considered a factor of that number. So the greatest common factor is the largest number that would divide evenly into another number, whereas the least common multiple is the smallest number that any two numbers would multiply into or divide into evenly. That's a lot of words for mathematical stuff that I know it's hard. It's easier when we're working it out as a problem, but you can go ahead and look on page 120 of your textbook and you can study real quick some of the first 6 non-zero multiples. In this case, they've given us 2 and 3. So multiples of 2 is 2, 4, 6, 8, 10, 12, which we actually just did in our sequence exercise. Multiples of 3, 1 times 3 is 3, 2 times 3 is 6. So 3, 6, 9, 12, 15, and 8. Remember, when it says non-zero, that means you don't multiply that number times 0. You just start with that number times 1. And so all of those numbers are multiples of 3. You will notice that all of those numbers are equal to or greater than 3. So remember, a multiple must be larger than the number you're comparing it to. And in the case of comparing two numbers, that multiple must be larger than those two numbers multiplied together. Okay, so, or must be larger than both of those factors, those numbers. So let's just go ahead and get into the PowerPoint real quick. So example 1 that they have there for you on page 121 at the top, it's wanting you to identify the common multiples of 4 and 6. So you can see with the multiples of 4, they've given the multiples way up there, 1, 2, 3, 4, 5, 6, 7, 8, 9 multiples of 4, and then the multiples of 6. So you see that the two numbers have 12 in common, they have 24 in common, and then they have 36 in common. But the least common multiple is the smallest number that they both divide into evenly. So 12 is the least common multiple of 4 and 6. So here we have the definition of least common multiple, and then you've also got it in the middle of page 121. It is the least common multiple, or LCM, of two or more numbers is the smallest positive common multiple of the given numbers. So let's go ahead and do skill check 1. Okay, so numbers 1 through 4, find the least common multiples by listing multiples. I would like for you to pause the video and do it yourself. Give it a try and see how you do, and then check your answers here. So first we do the multiples of 4. Excuse me. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, and 4 times 6 is 24. We'll go that high and then see if we can find at least a common multiple between these two. All right, let's look at multiples of 5. 5 times 1 is 5, 5 times 2 is 10. Then 5 times 3 is 15, 5 times 4 is 20. 5 times 5 is 25, and then 5 times 6 is not 60, it's 30. All right, excuse me. So you can see that the least common multiple of 4 and 5 is the product of multiplying 4 and 5 together, which is 20. So the least common multiple of these two is 20. Let's try this again. All right, look at number 2. Multiples of 7. We have 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21. Hopefully you've already seen we have a common multiple here. But 7 times 4 is 28. That's as far as I'm going to go. 14 times 1 is 14. 14 times 2 is 28. 14 times 3 is, 30, 40, 42. And then 56, I think. Yeah. All right. Well, quickly, because we're looking at 7 and 14, and we know 7 goes into 14 2 times. We really didn't have to go up that far, but you know that 7 times 2 is 14. 14 times 1 is 14. Therefore, the least common multiple of these two is 14. So that's a great example of how the least common multiple of two numbers can be much smaller than those two numbers multiplied together. Because if you try to just multiply them together and say, oh, this is it, then you're going all the way to 14 times 7, which is 98, when in fact 14 is much, much closer. All right, well, let's look at number 3, multiples of 6 and 9. So 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. I think we found one already. 9 times 1 is 9, 9 times 2 is 18. There we are. I'm going to go a little bit farther. 9 times 3 is 27, and then 9 times 4 is 36. But you can see here that 6 times 3 is 18, and 9 times 2 is 18. Therefore, our least common multiple between these two is 18. All right, last one. Let's look at 3 different numbers here, multiples of 6. So, 6, 10, and 15. Find what our least common multiple is. So 6 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, and 6 times 5 is 30. I'm just going to go ahead and go up to 36. All right, let's do 10. 10, 20, 30, 40, 50, and 60. Easy enough. Multiples of 15, you have 15 times 1 is 15, 15 times 2 is 30, 15 times 3 is 45, 15 times 4 is 60, and I'll do one more. 15 times 5 is 75. All right, so hopefully you know when you're comparing multiples of 10 that you need to look for numbers that end in 0 in the other two. So we have a 30 in 6. We also have a 30 in 15, and we have a 30 in 10. So therefore, our least common multiple is 30. All right. Hopefully that was clear. Let's go ahead and move on. Okay, so take a look at the bottom of page 121. They have a box there about finding the least common multiple. You can use prime factorization to find the least common multiple. And then they give you the steps below, which show you how to do that. So how to find the least common multiple of 120 and 90. So first, you calculate the prime factorization of the given numbers. So in the case of 120, it's 2 cubed times 3 times 5. And for 90, it's 2 times 3 squared times 5. So you circle the highest power of each different prime factor. You don't have to break them up into individuals like we do when we calculate greatest common factor, because we need each base prime number but we only need the one with the highest exponent. So in the case of 120, 100, they both have 2, 3, and 5 as their base prime numbers, but 120 has 2 cubed, whereas 90 has just 2. So we would need the 2 cubed to bring that into our least common multiple, because 2 cubed if we tried to use just 2, then 120, it wouldn't be a multiple of 120. So 2 cubed, then we look at the base number 3, and we have 120 has just 1 3 with no exponent, and 90 has 3 squared. So we need the one that's 3 squared, 3 to the power of 2. And then they both have a base 5 with no exponent, so you can bring either one of those down. So then step 3, find the product using the highest power of each prime factor. So your least common multiple is 2 cubed times 3 squared times 5. Well, 2 cubed is 2 times 2 times 2, which is 8. 3 squared is 3 times 3, which is 9. And then times 5. So 8 times 9 is 72. And 72 times 5 is 360. Therefore, 360 is the least common multiple of both 120 and 90. So that means that is the smallest number possible that 120 will divide evenly into 3 times, and 90 will divide evenly into 4 times. All right, so let's look at example 2 that you've got in your textbook at the top of page 121. So they want us to find the least common multiples of 25 and 55. So 25, when you do the prime factorization, 25 is 5 times 5, which is 5 squared, and 55 is 5 times 11. So 5 squared is the largest value with the base prime of number 5. But then you also have the 11, and you have to include, even though that 11 doesn't exist in 25, you have to include it in your least common multiple. So this is sort of the opposite of the greatest common factor. You include those numbers that don't exist in all of the numbers you're comparing, all the prime factorizations you're comparing, because they have to be included there. So your least common multiple is 5 squared times 11. So 25 times 11 is 275. That is the smallest number that both 25 and 55 will divide evenly into. So let's go ahead and let me make sure there's no other notes I need to include. Well, yeah, we'll just continue with the skill check. Okay, so skill check 2 says find the least common multiple by using the prime factorizations given. So in this case, they've given us, for number 1, they've given us 9, which is 3 squared, 3 times 3, and 12, which is 2 squared times 3. So we have a base prime number of 3 for both, but the one with the 9, the 3 squared, that is our largest value, or the largest exponent with the base number 3. And then in 12, we also have a 2 squared, so we have to include that in our answer as well. So our least common multiple is 3 squared times 2 squared. If you need to, break that down. So that's 3 times 3, which is 9, times 2 times 2, 2 times 2, which is 4, and 9 times 4 is 36. So our least common multiple of 9 and 12 is 36. All right, let's look at number 2. We have 18, which has a 2. There's no 2 in 27, so we'll include that 2. There is a base prime number of 3 in 27 and 18. 18 has 3 squared and 27 has 3 cubed. So since 27 has the higher exponent for the base 3, we would include that one. Excuse me. So this actually just becomes 2 times 27. 2 times 7 is 14. Carry my 1, so 54. Excuse me. 54 is the lowest number. It's the smallest number that both 18 and 27 will divide evenly into. All right, on to number 3. So number 3 has 21, which has a base of 3. There's not a 3 in 28, so we're going to include that one. They both have a base 7. with no exponent, so we have to include that. And then 28 has this 2 squared, and so we also have to include that in our final least common multiple. So that simplifies to 2 squared, which is 2 times 2, so 4. 4 times 3 is 12, and 12 times 7 is 84. So 84 is the smallest number that both 21 and 28 will divide evenly into. All right, so number 4, we are once again comparing 3 different numbers. So 20 has 2 cubed. There's a 2 in 20, 30, and 40. But you can see the 40 has the higher value. So we need to include our highest exponent. So we include that one, 2 cubed. There is a 3 in 30, and there's not one in any of the other ones. So we have to include that one. And then there's a 5 in all 3 of them. They all 3 have the same exponent of 1. So you only need 1 5 there. So that simplifies 2 times 2 times 2 is 8. 8 times 3 is 24. And 24 times 5 is, let's see, here my 2, that's 120. So the least common multiple of both 20, 30, and 40 is 120. Let's see, you know what? I think there's some I actually left off of here, but we won't worry about those. We can do those in class when we get back together. Let me go ahead and make sure there's nothing else we're missing in our PowerPoint. Actually, let's go ahead and do the last part of our skill check here. So we are asked to find the least common multiple of each pair of numbers. Let's look at number 5. So we're comparing 40 and 100, and we want to find our least common multiple for these two. So just if you want, flip your paper over. If you're doing it on notebook paper, just go ahead and write this down at the end. But if we wanted to compare, let's see if I can go. Here we go, give myself some room. Okay, the least common multiple of 40 and 100. I think that's where I was at. Yeah. All right, so go ahead and break it down into its prime factorization. 2 goes into 40 20 times. 2 goes into 20 10 times. And 2 goes into 10 5 times. And we have our prime factorization for 40 of 2 cubed times 5. Right, 1, 2, 3 2s. All right, 100. I'm just going to do 10 and 10. 10 times 10. This is 2 times 5, and this one is 2 times 5. So for 100, we have 2 squared times 5 squared, which makes sense. 4 times 25 is 100. All right, so let's look at our prime factorization here. We both have a 2, but 40 has a higher exponent. So 2 cubed, just least common multiple, equals 2 cubed. And then when you look at your 5, you see that the 100 has a 5 squared, which is the higher exponent for the base number 5. So that's our least common multiple. 2 times 2 times 2 is 8. 5 times 2, 5 times 5 is 25. So 8 times 25 is 200. So 200 is the least common multiple of 40 and 100. And that was, I think, number 5 in skill check 2. So for number 6, I think we're comparing 60 and 75. Yep. All right, so 60 and 75. 60 breaks down to 2. 2 times 30 is 60. 3 times 10, and 10 is 2 times 5. So we have 2 squared times 3 times 5 is the prime factorization of 60. 75, we have a 5. 5 times 5 goes in 7 one time with 2 left over, so 15. Excuse me. And then 15 is 3 times 5, both which are prime numbers. So 75 has a prime factorization of 3 times 5 squared, because there's 2 of them. All right, go ahead and compare those. We do have a 2. There's only one, so we'll just have to use that one. The least common multiple is 2 squared. We have a 3 in both, but there's only one, so, or they're both exactly the same. So just grab one of those and add it to your least common multiple. And then there's a 5, a base number 5 in both, but the 75 has a higher exponent, so we have to use that one, 5 squared. All right, so that becomes 2 times 2, which is 4, times 3, times 5, 5 times 5, which is 25. 4 times 3 is 12. And 12 times 25, I'm just going to do my multiplication here. 5 times 2 is 10, carry my 1, that's 6. 2 times 2 is 4. 2 times 1 is 2. So 0, carry my 1, so 300. The least common multiple of 60 and 75 is a big old number, 300. All right, so let's go ahead and finish up our additional problems. So these are just some extra practice. So for number 1 and number 2, we're just asked to list the first 6 non-zero multiples of each number. So again, this is 4 times 1, and you can do this. 4 times 1, 2, 3, 4, 5, and 6. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20, and 4 times 6 is 24. Same thing with 6. 1, 2, 3, 4, 5, 6. 6 times 1 is 6. 6 times 2 is 12, 18, 24, 30, and 36. And that's all we need. Now for number 3, we use these lists of multiples above to find your least common multiple of 4 and 6. So start with the first number. We have 4, we have 6. Nope, 8 and 12. And then when you look at the 4, you have another 12. So 12 is the first number you come to, the lowest valued number that both 4 and 6 divide evenly into. Therefore, 12 is the least common multiple of 4 and 6. So for number 4 and 5, we are using prime factorization to figure out the least common multiple of 45 and 75. So 45 is 5 times 9, and 9 breaks down into 2 3s. So the prime factorization of 45 is 3 squared times 5. 75, we just did. I'll do it again. 5 times 15, right? 1 and then, no, 15. That's a prime number. And then we have 3 and 5, which are prime numbers. So 3 times 5 squared. Now, I like, especially when they get longer, I like to list these underneath each other. Makes it easier to notice the similarities. So 45 is 3 squared times 5. 75 is 3 times 5 squared. So they both have a base number of 3, but 45 has a higher exponent. So we use that one. So 3 squared. They both have a 5, but 75 has the higher 5 exponent. So that's 5 squared. This becomes 9 times 25, which is, here my 4, 18 plus 4 is 22. So 225 is the least common multiple of 45 and 75. All right, and then for 7 through 10, they've given us a set of numbers and we need to calculate which one, what the least common multiple of each of these is. Excuse me. Okay, so I am just going to go ahead and do prime factorization for 8 and 18. 8, well, I know that 8 is 2 cubed. And you can do the tree if you want. You probably figure it out on your own, that this is 3 times 6, which is 2 times 3. So 18 is 2 times 3 squared. So we have 2 cubed times 3 squared. That becomes 8 times 9, which is 72. So 72, which that could have taken us a while if we were using the list of multiples, because you would have to have gone through 9 non-zero multiples of 8 to finally find 72. So that's why the prime factorization can be much faster. 20 and 28 is probably going to be similar. I know that 20 is 4 times 5, and in prime numbers, 4 is 2 squared. So that's 2 squared times 5. And 28, we know is 4 times 7. So again, we have 2 squared because that's our 4 times 7. So they both have a 2 squared. This one has a 5 and this one has a 7. We got to include all of those. So 2 squared times 5 times 7. That's 4 times 5, which is 20. And 20 times 7 is 140. So 140 is the smallest number that both 20 and 28 will divide into evenly. That is the definition, your least common multiple. That's what you're looking for. All right, so 12, 15, and 18. We just got 18's prime factorization, so I think we can write these out without the trees. 12 is 4 times 3, which is 2 squared times 3. 15 is 3 times 5, which are both prime numbers. And 18, we did a number 7. So I'm just going to take that 2 times 9. So 2 times 3 squared. So we have a 2 in 12 and 18. 12 has the highest exponent, so we use that one. They all have a 3, but 18 has 3 squared, which is our highest exponent. And 15 has a 5. And even though the other two don't have it, we have to include it because all prime numbers that exist in the numbers you're comparing have to go into the least common multiple. So 2 squared is 4, 3 squared is 9, and 5. That's 4 times 9 is 36 times 5. So 36 times 5 is 30, carry my 3, that's 15, 16, 17, 18. So 180 is the smallest number that 12 will divide evenly into, 15 will divide evenly into, and 18 will divide evenly into. Excuse me. Okay, guys, last one. Comparing 30, 75, and 105. 30, I'll just do my tree here. That's 3 times 10, which is then 2 times 5. I cannot get my throat. Hold on. Let's see here. I need something to drink. Okay. 75. So 3, 2, 5. 75. I didn't give you all much room, did I? 5 times 15, which then becomes 3 and 5. And then 105. Let's see here. That is definitely 5. 5 gets 10. Hold on. That was messy. 5 times 25. No, 21. All right, and then 21 becomes 3 and 7. Those are all prime numbers. So 30 is 2 times 3 times 5. 75 is 3 times 5 squared. And 105 is 3 times 5. Hold on, 5, 3, 7. Yeah, 3 times 5 times 7. All right, so we have a base of 2 with no exponent. So we got to bring that over. There is a 3 in each one, but they're all the same. So we'll just find one. You only need one of those. And we got this covered. 5, there's a 5 squared, and 5. So we got to use the 5 squared, the one with the higher exponent. And then we have a 7 and 105, so we got to include that as well. Okay, so 2 times 3 is 6. 5 squared is 25. So I'm just going to go 6 times 7, I know is 42. So let me do 42. This will be a big number. 42 times 25. 5 times 2 is 10. Carry my 1. 5 times 2 is 21. 2 times 2 is 4. 2 times 4 is 8. All right, so 0, 5, 8, 9, 10. So 1,050. That's a big one. So 1,050 is the smallest number that 30, 75, and 105 will all divide evenly into. All right, so that is it for today. Today's lesson. Once we get back in class, we'll work through the homework problems together to make sure that we all understand these concepts and can get a little more practice. Otherwise, I will see you guys later. Thanks so much. Bye.